Okay, here we go. Let's prove that the angle EDF is congruent to the angle GDH. These are, let's see, EDF is this big flat obtuse angle up here. GDH is this big flat obtuse angle here. That is the statement that I want to end with. I'm going to paste it down in this box. I'm using Control V. No, I'm sorry, I'm using Control Shift V so that it doesn't retain formatting. So that's why I didn't get yellow stuff in here. That's why it's small enough to fit. Now, I need two overlapping linear pairs, and that overlap will be subtracted. So once we subtract that overlap, we need to end up with angle EDF and angle GDH. So I think my overlap will be FDH. So my first linear pair will be EDF, FDH, and I'm going to say that those two angles form a linear pair. Okay, and the verb is not they're congruent. The verb is they are a linear pair. And it didn't fit, so I'm going to make it smaller. I'm going to use that size throughout. Yeah, it's small. It'll be okay. Okay, so those are a linear pair, EDF, FDH. Now I need the linear pair that creates an overlap. So GDH, FDH. I'm going to paste that in here. GDF, FDH, and that needs to be 8 points in order to fit, or smaller. Maybe if I just pull that out a little bit. There we go. Oh, we're doing 7 points, are we? Okay, so let's do 7 points. So what's the reason that we know those are a linear pair? The reason is the diagram tells us. So all you have to do is put the word diagram. Don't type it twice, copy paste it. Okay, now I'm taking my advice from these arrows that are over here. Each linear pair is made up of two supplementary angles. So I'm going to just copy paste this. Let's make sure I did this right. GDF, FDH. It should be GDH, FDH. GDH, FDH, EDF, FDH. So the FDH is going to be subtracted out of there. Let's grab these, and we're going to claim that since those form a linear pair, that they are supplementary. And this will be the linear pair postulate. And do the same thing over here. Since they are a linear pair, they are supplementary. What's the reason for that? Linear pair postulate. Don't type it twice. And I'm trying to be consistent, so I'm going to make that a lowercase l. Copy that. Copy that, Roger. Paste it in there. Get rid of the extra carriage return that pushed that down. What is the meaning of supplementary? Well, according to the definition of supplementary angles, which I will use twice, if I add these together, I get 180 degrees. So add the measure of each angle, and we will get 180 degrees. Don't forget about the measure over here. And don't forget about degrees. Insert special character, degree. There it is. Let's see, I'm going to use those again, and I'm going to replace that carefully with what is above it. So this should be GDH. Now remember, as I told you in class, and FDH, these vertical angles all meet at this vertex called D. The vertex D will be common to all two of these angles, both of these angles. It's 4 at this point. Later on, it'll be 2. So I see D here, D here, D here, and D here. Okay. All right. Since this equals 180 degrees, and this equals 180 degrees, they must be equal to each other. What's the reason for that? Our good friend, the transitive property. I have an FDH on both sides. Let's subtract that from both sides. I'm subtracting the same amount from both sides, getting rid of the FDH that's on both sides of this equation. And I can do that because of the subtraction property of equality. Finally, I've reached my final statement. How do I know that those are congruent? Because of the definition of congruent angles. I would double check that it says EDF GDH, which it does here. Double check EDF FDH, EDF FDH, double check GDH FDH, and we're done.